We have studied three different types of functions: linear, exponential, and quadratic. So if you remember, we've spent the most time on linear. Linear line means a straight line, and we have our standard form of y equals mx plus b. An exponential model, remember, we can have exponential growth or exponential decay. And what I want us to focus on here with exponential, and I'm going to actually write a simpler form of an exponential model. We had y equals a times b to the x, where b here is our growth or decay rate. If it was a number greater than 1, it was growing. If it was a number less than 1, between 0 and 1, it was decaying. Okay, so our exponential growth, remember, or exponential decay is going to be changing by the same rate every single time. We also have our quadratic model, and our quadratic model had an x to the squared to the second power. Notice here an exponential model is being raised to the x or to the t. In a quadratic, it's to the second power. And we had the shape of the graph was parabolas, either opening down or you could have them opening up. And I do want to write a little bit, we're going to focus as we're writing models today just on the simple version of this, a basic simple y equals ax squared. Okay, because we are going to be writing these models, and these are the forms we're going to want to use. So these are the three models we've been studying. Linear function is a straight line. And excuse me for 1 second. Sorry about that. So anyway, we're going to be focusing on these three models: our linear model, our exponential model, either growth or decay, and our quadratic model. So the first thing we're going to do is we're going to have to decide which model fits each type of data. So if you notice here, we have three sets of data, three relations. And what you want to do is you want to sketch the graphs. Basically, just plot these points and see what the model looks like. Now, I am going to use a program here. So the first one, if I plot the points in, remember the first one was -1, 1, -1/2, 0, -3.2, I'm sorry, -3/2. So if I plot those in, and I'm going to write it as 0.5, and -3/2 is a -1.5. And 5/2 is 2.5. Again, just sketchies on a graph. Just for the sake of time, I'm going to use this graph right here. But if you look at, you can kind of get an idea of what type of model this is. It's not going to be linear, it's not a straight line. Is it exponential or quadratic? Well, since we can see that it's coming down and going back up, we're going to call this a quadratic model. Okay, because the shape of the graph is a parabola. Let's try the next one. We have -2, 5.5, -1, 1, 0, -1/2, 1, and -2. So if I'm just going to plug these in, again, just sketch a graph. You do not need to make a very involved graph at all. This graph looks pretty linear to me. It seems like everything's lying on a straight line. So I'm going to call this set of points here, this relation, linear. Okay, and before we just assume what this last one is, let's try it. I did convert all of these to decimals. So -1/5/4, I'm going to write it as -1 and then 1.25. 0 and 5/8, I'm going to write it as 0 and 0.625. 1 and 5/16 says 0.3125. And 2 and 5/32 is 2 and 0.15625. Now if you look at this, it does look exponential. It also could look quadratic, so be very careful about that. And I'm going to show you in a couple other examples of how we can tell the difference between quadratic and exponential. But since these points don't show the symmetry of it's coming up in a parabola, I'm going to go with the assumption that it's exponential. It's getting closer and closer to 0, never really hitting 0. It looks like it does here, but it doesn't. It just keeps getting closer and closer to it. So we will call this last example exponential. These are the 3 types of models we're working with today. And in other later examples, we're going to be actually writing equations or writing functions based on these models and based on the graphs we create.